Sorry, yeah, hello. So I'm going to try to speed through this and then I'll type anything or you can tell me any questions through email. So the video is not very long because when videos are very long, we stop watching after 6 or 7 minutes. We stop watching. Okay, so let me share my screen and show you the things that I have up here. That's not one of the things that I need. Okay, so these are the homework sets, but let me just go back here. And I'm going to show you, my bad. I'm going to show you what I'm going to email to you. I thought it was open. Okay, unfortunately it looks, I can't see it. Okay, so this is a solution that my father sent for the first two problems. And it's 10 points and 10 points. For this one is using Bernoulli equation and being very careful with the units and knowing that the elevation is the same. And you should take a look, you should read the problem before you look at the solution. So you can do that and try to remember a little bit of fluids. And this is mostly Bernoulli equation applied to one inlet and one exit and knowing that the elevation stays constant. For this one over here, this is problem number, did I just send? No, this is problem number 2, the one that I was talking about. Why did I grade that as problem number 1? Doesn't matter. Okay, and then problem number 1. What is this? This is problem number, okay, this is problem number 1. Doesn't matter. That's one problem and this is another one. For this one, it's also using Bernoulli equation. So you start with that and I'll talk about how I dealt with the points. And then for this one, the velocity at 1 is going to be very small. You're trying to find the velocity at 2, okay? Or the velocity at 1 is almost 0 or much smaller than the velocity at 2. So again, you should look at the problems, at the problem statement before we get to this. And this is a solution that he sent me, and this is a solution that I did. So I wrote all these things using pencil, so it would look different. But now when I scanned it, it looks like it has pen as well. So you can take a look at both sometimes, or you can take a look at just mine. But a lot of the comments, you can see the handwriting is different and little clouds with points, that's from me. Okay, so I'm just going to focus on mine over here. But again, I'll send both of these to you. And now I'm just going to go a little bit over the comments that I wrote. For problem number 1, okay, they start with Bernoulli equation, then they say the elevation is the same. Therefore, I simplify the equation to something else. So here I wrote some comments. They may not explicitly state that the elevation is the same, and they might just go straight to this equation over here. P2 is equal to P1 plus something else, right? So in that case, they still get the points. It's just in case they get something wrong, then you can go back and give them partial credit. Same here, it's 1 point for this part over here. If they get this wrong, okay, they lose this point, they gain 1 point, where they get 1 point for the equation. Unfortunately, that density, right, using the ideal gas equation of state, that density is going to affect this value over here, all right? And there's a comment down here. Now I'm not going in order. You might be like, what is she doing? If they get this wrong, because the density is wrong, they still lose. They still lose 1 point, okay? Because they already have 1 point for the equation over here. So yes, it might seem unfair because you get something wrong, you get everything else wrong, but you're still getting points because of the equations being correct, okay? Same here, the equation for V1, Q divided by A1, they get 1 point for that. If they don't write it, they just go straight to this, then that's fine. They don't need to write it. It's just if this is wrong, they get partial credit here, okay? Sometimes it's really hard to grade some of these problems. They just write this equation equal to something, just already solving it. And then if it's too tough to grade, you can just send it my way. Otherwise, you can be lenient, but be fair and consistent, and I'm sure you'll figure it out, okay? Now, here, same thing. I wrote a comment over here for the area. This is partial credit. Maybe they solve for everything at once, similar to what my dad did here. Here they did V1 is equal to this, V2 is equal to this. So maybe they just went to this equation over here for pressure 2 equal to pressure 1 plus 1/2 density, and then they substitute in here, Q divided by A1, and then here Q divided by A2. If they did that, then it's easier to make a mistake. And they might not get all the points if they get it wrong, but they don't need to explicitly write these, okay? For problem number 2, this is taking longer than I wanted. Problem number 2, something similar. here I write half a point for the original Bernoulli equation, half a point for the equation, assuming that the velocity at 1 is very close to 0. So if they skip that step, and they start with this equation, that's fine, because it means that they just knew it. However, if they start with this equation, it's like, where does that come from? So there should be 1 point from writing down Bernoulli equation at some point, okay? So whenever you don't know if it's a comment, again, I try to do it different, but if it's a comment or if it's something that my dad wrote, just go back to the one that doesn't have my comments. So here, these 3 parts, when you're solving for this equation over here, there's one that has change in pressure divided by density and one that has 2g divided by the changing elevation. And this will be 1 minus 2. So here, my dad did that in different parts. Okay, he did this part is equal to this part is equal to this. I put them together, but sometimes students, I did that too. Sometimes we just put all the values in here and solve for V2, so they don't have to explicitly do it this way. But if they don't do it this way, then it's just easier to make a mistake and it'll be harder for you to find where the mistake is. Here, the same thing, they get 1 point for the equation already. So if they get this wrong, they would lose 1 point, okay? The value itself. Again, the units should be included here because that's what the problem is asking for, okay? So it'll be the volumetric flow rate or volume flow rate. I don't know what my dad calls that, okay? All right, so now I'm just gonna grade a problem number 2. The plan was to check it. Okay, let me, no. All right, so what we'll do is we come to this page over here, we go to grade homework number 2, and something like this will show up. And this first one, what's going on? It's already been 7 minutes. All right, so this is longer than I anticipated. For this one, the student said that the handwriting is poor because they broke a bone or something, they broke their thumb. So I wrote for you. We hope you get better. You don't have to do anything like that. For this one, I'm gonna leave that up to you because I can't see that very well. So I was trying to choose some problems that were not right, and I should have looked at this before I started recording. And then if you see something like this, two homework sets, you grade the one that was submitted later or the latest. They have many, okay? So let's see. Let's do Noelia. Okay. All right, so we have problem 1 over here. I have it here, but you would have the files over there. So problem 1, which one is problem 1? Right. So here I noticed that they have the Bernoulli equation and that they said that the elevation, no, this is not 0. That's fine. It just means that the change is 0. So that's fine. So that's the point. So I'm not going to write +1 or anything like that. If I wanted to make a comment, I can either click on this, like, hey, good job. And you can change the colors over here. But if there were only 4 students, you could write a bunch of comments for a good job. But otherwise, it's well, I usually write comments or minus something when there's something wrong. Or you can have a bubble if there isn't a lot of space, and you can leave a comment. Okay. All right. So here, Bernoulli equation is right. I'm looking at the solution. They do have to find the density. We talked about that, but I don't see them finding the density here. Let's see. Bernoulli equation is right. Then okay, so see, this is why they make it complicated. If we look at our solution, we need to find the density using the ideal gas equation of state. And I don't see that here yet, but it might be here at some point. Here they said V1 is Q divided by A1, and the area is here. So not exactly like what my dad had, but she's following the steps. Again, 9.314 meters per second, V2, 37.26 meters per second, that's fine. And now she said that the pressure is, or they said, they said, I don't know, the pronoun will be P1 plus 1/2, and here is where they have the density, even though they don't have it in an equation explicitly somewhere. And let me look at that equation. That will be P times molar mass divided by RT. They have all that here, the calculation of that, even if they don't have it explicitly, because the problem is not asking for the density itself. And then they get that the pressure is 137.446 kilopascals gauge. Why is that? It's a problem asking for gauge. So if you look at the solution, we had 238.45 kilopascals, what my dad had in the problem. So if, I don't know if you remember, but absolute pressure is atmospheric pressure plus gauge. So let's see. Let's see what the problem said. Starting out, all right, it says atmospheric pressure is 101. So 101 plus gauge should be absolute. So let's see if that's what happened here. Let's see what the problem was asking for. We go to homework. It can never be just straightforward, huh? Homework solutions. That's not what I want. Homework files. Homework 2. Problem 1 is asking for the pressure in the smaller pipe. All right, so in this case, what I'm going to do, because I noticed that this is one interesting problem, I'm going to calculate this V1 squared with my phone because I don't have my calculator with me. There's my calculator. Oh, right here, found it. All right, just because I want to make sure that the 238.45 kilopascals that my dad has in his solution, I want to make sure that that he calculated is absolute, okay? If that is absolute, then if I subtract 101 kilopascals, I will get gauge, and then she would have it correct, okay? So V1 squared, 9.314 squared minus V2 squared. You're like, no, it's supposed to be 5 minutes. What is happening? Let's divide by 1,000. Multiply by density. P1. It will be 241. Okay, so this is an important part. Okay, when you look at the solution over here, that value, I don't see that step here, but for P1, yes, it's right here. My apologies. For P1, let's see if you did that as well. Yes. For P1, for the density calculation, you have to use absolute. So then my dad continued the problem and calculated P2 absolute. And if the student gets that, that's fine. They don't even have to write that as absolute. But here, the student has this as gauge. And that is correct because it will be absolute minus 101. Okay, so that is correct. So I don't even write anything. You can write good job or something like that. If the student has them all right, I can just put 40 at the end. If they have everything correct, I would just put 40. Click on the side. All right, and the grade is saved. But I'm not going to do that. Okay. For now, I'm going to write a comment. Grading so far. So you have that information when you grade problem 1 minus 0. Okay. Now let's look at problem 2. It's been 14 minutes. I'm sorry. This might be important. So problem 2. It's not right. So it looks like I'm going to have to look at other parts of the problem. Okay, so for problem number 2, we have the Bernoulli equation over here. And there's a problem almost immediately over here. Well, not necessarily. Depends on where she has 1 and 2. Okay, if I look at the solution, my dad had 1 at the top and then 2 at the bottom.